Okay, we'll give this a try. Hello everybody. Weather's finally turned cold. I got finished with a lot of my outside projects. It's time to get inside now and maybe have some fun. I've been experimenting. From the last video I've talked a little bit about receiver circuits that could run on 28 volt. And there's quite a lack of parts available that would work good for a full Superhet receiver. That's one that's got Iaf's intermediate frequency stages instead of just a like a super regen or what they call a regenerated receiver. Those work on low voltage, but they're really prone to being broadbanded. If there's several stations out there, you can't really tune in, and they have a really high noise level, a hiss, that's just typical of a super regenerative radio, a receiver, and it makes it hard to hear real weak stations. But a Superhet has an RF amplifier stage and then a local oscillator, and it mixes the incoming signal with the local oscillator, converts that to a new frequency called an intermediate frequency, and in this case 455 kcs, which is a fairly common, or was, transformer to get. The standard, let me grab, if I can get my hands on it. Alright, the standard looking Iaf transformer, make sure I'm in focus here. Okay, the standard transformer looks like that. Now that's something that I've shown in other videos that you could pull out of old CB radios, similar to a Johnson Messenger 1, the Johnson Messenger 2, and then there was a Johnson Messenger 202, which was a business band radio, still on the all on the CB band, but they had receiver circuits that used the 455 kc Iaf transformers, and they look like this. These are like unobtainium all of a sudden. I didn't realize it until I was just going to go on eBay and suggest some sources for people could find them, and I was quite surprised. There was a very bad lack of those kind of transformers, and when they were out there, they were from $15 to $20, $35 a piece. So I kind of went back and did some rethinking to figure out if there's any other way that I could direct somebody that wanted to build a receiver to something that's more obtainable. And I lucked out. I found something that actually works. I ignored it for a long time because I thought, since they worked with, they were in a transistor type radio, and here's what I'm talking about. This is loop stick antenna. This would have been inside of a toy, maybe a little stuffed animal, like a little teddy bear or whatever, or some form with a speaker in it. And it was just a straight little AM radio. And the important part inside these things, this one you'd ignore. It's got a red core. That's the local oscillator. But it's this one, and this one. These three transformers are what you want. Pulled out of the circuit, they look like that. Really small. I mean, big, oh, where'd I go? There. Big difference between the two. So, for the longest time, I thought that these wouldn't work. So just like I said, I ignored them as a source to actually make a receiver that worked. But that's what these 3 transformers are. And in this circuit, so that you could receive CW or sideband, I tried one more and made what's called a BFO, a beat frequency oscillator. And what that does, it's an oscillator that runs at 455 kCs and puts a heterodyne on the IF channel and beats against the incoming signal that you would get at the end of the IF chain, and that will turn a CW note into a tone. Or in sideband, you could tune it above center frequency or below center frequency and be able to receive a sideband signal. You just dial it in, listen to their voice, and it works. This little circuit really works. And these transformers, they're hooked up in the circuit. If you find schematics for them, you'll find that the, let me find something I can point with here. In the transistor circuit, they're tapped, and the transistor collector will be on this tap right here. Well, in tube circuits, we can ignore that because we need the higher impedance. Since transistors work on a little lower impedance, they tap down, but the whole coil has to be there so it resonates at the 455 kCs. So if you ignore, you can see it's so small, maybe I'll lay it on the side. This little center wire tap right here, you can ignore that. And the 2 output legs, let me turn it where you can maybe see them, here and here, we just use them normally and hook it right to the grid. Each grid needs a little bit of bias, so we have a 2.2 meg resistor and a cap that we put on each one of these, and that sets the bias for the tube. And I was just really surprised when I tried this on a circuit that I built, and the thing really works. It receives good. Here is the receiver. There's the little transformers. Now the tube I'm using, I had to even experiment around to find the right tubes that would work at 28 volt. And the tube I'm using, where'd I put it? Show you one here. Here it is. It's a 6BH6. Now, if you end up with one of the Johnson Messenger CB radios, you'll have some of these in the radio. There'll be a 6BJ6. Same thing. A 6BJ or 6BH will work at the 28 volt just fine. And I'll show that here in just a minute. Let you see the circuit. Alright, where'd my pointer go? Alright, this line right here is the 28 volt line. I just feed it at one end, and then I can pick off when I need plate resistors. It's just a 1K resistor on each one. Local oscillator is right here. I use a 12BE6, and the tubes are hooked in series on the filaments. So there's 2 6BH6s here, and there's 2 right here. And I hooked those 2 in series and these 2 in series, and that makes 12 volts. And then I use a 12BE6, so all the filaments can run at 12 volt. The 6BE6 or 12BE6 is a local oscillator converter. Its cathode, first grid, and first screen are like cathode, grid, and plate, and just like a triode oscillator. But the other half of the tube gets the received signal in and then converts it to the 455 kC IF frequency, the difference frequency. The tube front end has a RF amp to receive, to boost the weak signals as they first come in. This simple setup, I originally was trying to get away from having to use a tuner on it. So what I was doing, this coil right here had a, I'm not sure if you can see it, but it's got a screwdriver slot on it. And I was just using it, but I found it tuned so quick that it was really hard to land right on one of the sideband frequencies. So I relented and went ahead and just mounted a little plate and a little gear drive variable capacitor. And see, it tunes slow. This is gear drive on the ends. These things might be hard to find. You might have to actually find what they call a gear reducer, or they referred to them as a velvet veneer drive, and they'd usually mount that on the front panel of a receiver. Your knob would go to the gear part, and then the outside, or the output behind the veneer drive, there'd be a little flexible coupling that would go to your variable capacitor. Okay, let's hook her up and show you. I don't know. I'll do it here in a minute. I've got a ICOM radio that I'm just going to listen to the 455 kC output of this. But first, we'll go tune into the noontime net and let you hear it direct.
All right, go ahead. Or they pulled into the place and having coffee on the side of the road or something. Okay, thanks, guys. I really appreciate you being here with me. I really do.
That's the noontime net.
Early session of the noontime net. Having a lot of fun getting folks checked in.
And that's at 7. Turn that down. 7.2835. 7.2835 kilohertz. That's where they're at, and it's lower sideband. So what I'm going to do now, I've got this pre-programmed in the radio. I'm going to go to the 455. Now that tone's coming from the radio itself. It has a birdie or a heterodyne in there, but that won't really bother us too much. Take this out. Okay, this is our antenna. Hook that there. We got to hook up a ground. Let me roll this way. And we got a filament lead. Hook it up to 12 volts. Get the tubes warmed up. See, that changes the voltage on a 12 volt supply. A little bit of a tone difference. Okay. Now, again, I've got one solar panel that is a 24 volt solar panel. We're in full overcast. We're supposed to get snow today, but we still get, let me see if I can show you on a voltmeter here. Got to get a ground. Okay, you can read that. It's 32.7 volts. That's what's coming in off the solar panel. No power supply needed. But even on a real cloudy day, a 24 volt solar panel unloaded will give you some voltage there. And that's what we're going to run the receiver off of today. I have it listed as 28 volt, but if you had a system up and running that had a 24 volt panel, you're going to have two 12 volt batteries in series, and the nominally fully charged voltage is going to be right at 28 volt. And the circuit will run on that, but it's just easy for me not to have a power supply. I'm off grid here, so I'd have to run an inverter and a transformer type power supply. But straight from the solar panel, I can get the voltage I need. Okay, we'll take this off and we'll go ahead and hook up the voltage. Gotta get on the come on. Okay. Now I'll find the end of my coax. I'll get in the radio. Alright, now let's see if we can dial them in. Kilo Oscar, KC6, we got you, Roger. Thank you, Kilo Charlie 6, Kilo Oscar. There it is. Did we have another station with a mic in the suffix? Kilo Fox 7, Whiskey, Mike. Kilo Fox 7, Whiskey, Mike, Mike. We have you, okay? Roger, thank you. Suffix. 37, Oscar, Tango, Quebec. Okay, two of you. KJ7, give me your suffix again. Oscar, Tango, Quebec. Oscar, Tango, Quebec. KJ7,
So there it is.
Now that's working
okay, we have you.
with the transistor Iaf transformers. They actually will work with tubes.
Whiskey 6 Alpha, Echo, Quebec. We have you too, Roger. Oh, you're entirely welcome. You have a good day. And who was the one that just came
So you just dial it in for what the voice. The radio is still set for sideband, lower sideband.
Okay.
And it's just set to receive 455 kcs on the ham radio.
Who was the QRP?
So now, what I'll do is I'll
Kilo Bravo 6, Quebec.
unhook the 24 over the plate voltage, and you'll see it goes away. There, not receiving. And we hook it up.
That's exactly it, something like that. 2688 Ferndale by this. Good morning. Okay, Ferndale, and you've got a good signal too. Okay, back to you, Scott, W7ZRC. What a great job, Rod. Thank you very much for that. Bringing those guys in and sorting
Okay,
out what
now
they're hearing when they all...
we'll unhook that. I'm going to hook the antenna back to the radio, and we'll go back to...
Fantastic signals to me here today, and that is wonderful. Okay, well,
now there's the radio receiving them direct.
For the early session of the noontime net. Let's spread them out,
So you
folks. I'll write down what I hear.
You see, there isn't a whole lot of difference. This circuit would actually work pretty good. My antenna isn't a dipole or anything. It's about a 50-foot piece of random wire that I just have coming in here to this lead, and that's what the radio listens to, and it can hear stations pretty good. You can go more elaborate if you have room,
Relay on CW.
but there it is.
Okay, very good. Got that out there. I'll turn
Now,
the filter back on so I don't get...
my next idea is if you want to do a build along, I will do the videos and build this up. What I'm going to do, I have another chassis here. You've probably seen this one before. I've done some experiments on some other circuits, 28 volt stuff on this, and there's enough room on here for me to put the whole 28 volt receiver on here. Right down, and I already have a variable tuner for my dial. These two caps are for the antenna and the plate of the first RF amp, and the holes here for the tube sockets. And let's see, where did I put the little little IF can will get mounted in these holes like so. Now, if you happen to have the right size of the transformer, like the transformers that would come in the Johnson Messenger type radios, you could go ahead and use them. You could download the schematic. They're on the eBay. You can find them. Or not on eBay. They're on the internet. Just look for Johnson Messenger 1 or Johnson Messenger 2 schematic. There was even another tube type radio. I believe I forgot about it earlier. I think they called it a 223 or 323, and it was a tube type CB radio. It was 23 channel, and they just used the same chassis. They just turned it sideways, and so it would use the same parts and pretty much the same schematic. But those IF transformers would work in here just as well. There is a little bit of tuning. There's a core in here, and there's a little difference from the transistors to the tubes. So when you get your IF strip totally assembled, you'd have to tweak or align each one of those transformers, and I can show how to do that if I end up doing this receiver build. Now, another problem that cropped up is coils. I didn't realize, again, this type of coil, this is for the, let me show the original receiver. Okay, if you can see that, there's one here and one here. These coils are for the RF amp. There's the antenna and then the plate of the RF amp. Those coils seem to be hard to find, the coil forms. Ideally, I like to use this type. You can see that in there. They have a threaded end on them, and they take a little ring nut. So all it takes is a little hole in the chassis, and this could just fit up through there, and then you screw the nut on it like so, and it locks it in place. And they come in all sizes. Here's a large one, same thing. It just has a ring nut on the end, and then if whatever there is on there, you can take that off and just rewind what you want. The schematic that I have drawn for this, for the 40 meter band or 7 megacycles, I use 35 turns, 30 gauge wire, and a variable cap to tune it. But for those that don't have, or you can't find, if these tuners here, if you can't find them, there is an option. A viewer in France showed me a picture of his coils, and this is when I realized that maybe not everybody can find the same parts. He wound his on a wooden dowel, a 1/4 inch wooden dowel, which will work equally well, but it makes it critical to get the right capacitance across there. And if these tuners can't be found, then what's needed is, and I've got it listed in the schematic, 35 turns on a 1/4 inch form. If you put 88 picofarad across there, will land this coil perfectly tuned at 7.2 megahertz, which lands you pretty much in the middle of the 40 meter band. Now, you won't be able to tune very far above or below the 7 megacycles, like you can go down into 5 or 6 megacycles without changing the caps. Obviously, if you want to tune down in frequency, you could just go more capacitance, like instead of 88 picofarad, you could try 100 picofarad. But whatever you do with one coil, you would need to do exactly the same to the other coil. And what that looks like, usually a silver mica. Not sure if the camera can pick that up. There's a little silver mica cap across there. And on these, I just used what I had available just to try it, because there's no tuners and there's no cores, so I just wanted to make sure that it would work. On one, I've used an 82 picofarad, which is close enough. And on another one is a 62 picofarad and a 22 picofarad in parallel across the coil. And both of them seem to work just fine. And that's without any core. Now by core, what I mean is this threaded rod that comes out is adjustable. And this is what it looks like on the inside. It has a little bit of powdered iron molded to that brass rod. And with the threads, when you tune it, you see it'll change the position that it's in the coil. Like that one, don't like that one. Okay. Some of these have ends that are closed a little bit. Now see, it would just slide in and out. This little end clips onto the cardboard and holds onto the rod while you're adjusting it. And it also has clips. You can find these on some coils where they'll have a clip. You get the hole just right, push it through, and these little wings grab onto the hole, the edge of the hole. So you'd have to have your hole pretty precise, and then you just shove them through and they'll snap in place. And if you don't have that, there's nothing that says you can't use. Let me find it. Right there. A soda straw. You could use that. Just cut a piece off, punch a little hole with a needle right close to the end of where your wire wants to go, and thread the wire through there to keep it from unwinding. And then maybe coat it with a little bit of fingernail polish or just something to hold all the turns together. Okay. What I was back to this. Let me know if you want to me to do a video on building this. Would start with the first stage, where you can see both one of them. The RF stage, that's the RF amp where the antenna comes in, will be this tube here. The mixer oscillator, local oscillator converter, the 12BE6 right here. And then once we get to that point, I'll just keep on going around here with the Iaf strip. There's one thing on this one I'm going to change, because I ran across a circuit that uses a 12BE6 as a product detector. So instead of a BFO, a 12BE6 may be able to be a local oscillator and come out just as a product detector. So you'd have a switch for AM, and that would turn this stage off. And the audio output of the last stage, you could just run it through a little, don't have it right now, but I think they're a LM386. It's a little 8-legged IC chip, and just with a few components and a volume control, you can output right to a speaker, and I think it makes like a 1 watt output, and it'll run off your 12 volt source. So let me know if you'd like to see a build session on this receiver, and I'll go stage by stage, each video for a different stage as it progresses through. So if there's any questions or ideas that I can't think of just right now, you can comment, ask, and any information you want I can probably fill in on as we go along. This schematic as it sits is the schematic of what I have right here. And it works. It's just that it's not convenient because it's in, I built it on this chassis just as an idea. I didn't want to go to build a complete receiver and then the stuff not work. But stage by stage I build it, and the thing seems to work just perfectly. You could, just by changing the antenna coils and the local oscillator coil, you can put this thing on 80 meters, 75 meters, or any other band that you want. And with, of course, with the product detector or BFO, then you could listen to sideband anywhere you want. In other words, you don't change the BFO, it just always would run at 455 kcs and then beats against the Iaf frequency. So let me know your thoughts. If you want to see the build on this, and we'll start in on it probably as soon as next week. Those of you that have been looking on one of the other videos about the transverter, the little rig that converts a CB radio to, in this case, 40 meters, and vice versa. In other words, you key the radio up and it'll actually put out a 7 megahertz signal. Just converts the CB radio up to 40 meters, and it receives. The same RF amp in this rig and local oscillator are pretty much exact to what the shortwave receiver, and it would use the same coils, same setup, same coils on the RF amp. I did that on purpose so that if somebody wanted to experiment with this, they wouldn't have to come up with different coils. They actually are the same 35 turns, bridged with the 88 picofarad or something close to it. And in this case, I didn't have to bridge the coils with a silver mica. I just simply used the variable tuners. Makes it more convenient because you can move the thing around. If you go clear off the end of the band, and you might want to re-peak your receive, and that's what these will do. But this project will be, I'll get back to it, probably again, the first pickup on this will be next week. I think where I'm at on this is I had the receive going, and it's the first stage of the transmit converter that takes the 27 megahertz, converts it to 7 megacycles on this tube. And I'll do that next week. But just to let you know, that's what's going on. Now that I'm back inside, weather's bad, I can get back to building this. So let me know your thoughts. If you want schematic or info, or want to contact me directly, there's how to do it. I'd be more than happy to send you the schematics to either that transverter project or the receiver project as we got going right now. Like I say, the schematic right here is ready. It has notes on it that talks about the coils or what you could use. And then you can contact me if you have any questions. But it's a JPEG. It's not very big. I think 200K, something like that. And then you can take and print it out and be able to follow along. But yeah, let me know what you think. Please like the video. This channel hasn't got very many viewers, and I don't know if I have no real way of knowing if anybody's interested in this. And the only way I can tell is if I get some likes or people let me know. And if you subscribe, please leave a comment for which one you want. Like YouTube has no way of saying because you like the transverter video, you might have subscribed there, versus the 28 volt receiver series. So just leave a comment, let me know, and I'll know there's people interested out there, and I can go ahead and make these videos. If there's no interest in it, I'll find something else to do. But yeah, let me know if you want to follow along, and I'll start making these videos. And if there's any other questions you have, yeah, you can contact me. So thank you for now, and everybody have a good Christmas and stay safe out there, and we'll see you next week.